Hello and welcome to the 3.3 notes, quadratic functions in standard form. In 3.1, we had an introduction to the quadratic function and what the graph looks like. And in 3.2, we took a deep dive into the quadratic functions in vertex form. Today, we're going to look at standard form. And before we get started and really define what standard form is, we're going to look at some of these differences and similarities in these graphs. So the very first picture I have here, I have a graph in red, f of x equals 2x squared minus 2x. I have a graph in blue, g of x equals 2x squared minus 4x. And in green, I have h of x equals 2x squared minus 6x. What we're looking for is how are these graphs similar and how are they different? So whether you compare the graphs or even if you look at the equations, you can come up with some things. How are the graphs similar? Well, they're all parabolas. They all actually have the same shape, right? They're a parabola and they have the same steepness. And this is because of the 2 that's in front of all of the x squareds, okay? So because they have a 2x squared, all of the steepnesses are the same. They all go through the origin. So they go through the point 0, 0. They all have that in common. They all open up. Okay. Let's talk about some ways that they're different. So they have different axes of symmetry. They're different for each one. They have each one has a different vertex. The plural for vertex is vertices. They'll have different vertices. You'll kind of notice that they're shifted down a little bit and moved over to the right. That's kind of the biggest differences. All right, let's compare these three graphs. So in red, I have f of x equals negative 2x squared plus 4x. In blue, I have g of x equals negative 2x squared plus 4x plus 3. And in green, h of x equals negative 2x squared plus 4x minus 3. So look at these graphs. How are they similar and how are they different? Ways that they're similar is they're all still parabolas. They all open down. They have the same shape, okay, the same steepness, right, because of the negative 2x squared. You may notice they all have let's write this differently. How about they all cross the x-axis? I'm sorry, I misspoke. They all cross the y-axis. They don't all cross the x-axis. And then ways that they're different. Their axis of symmetry is the same. But their vertex is different. They also have different y-intercepts. Now, when I look at this the equations, the only difference here is whatever I'm adding or subtracting at the end. So I have negative 2x squared plus 4x for all of these. And then for the red one, I have plus or no number. For the blue one, I have +3, and for the green one, I have -3. So looking at kind of what I've got over here, the red one I have plus no number. Check out this 0.00. The blue one I have +3. Check out this 0.03. And the green one I have -3. Check out this thing, -3. So actually, what we're going to end up learning is that whatever I add or subtract at the end right here, that's going to give me my y-intercept. And that's kind of why standard form is cool and why it's useful, especially when we're doing application problems. Okay, so the standard form of a quadratic function, here we go. We've talked about standard form of a quadratic expression. So the only difference is that I'm putting this in function notation and setting it equal to something. F of x equals ax squared plus bx plus c, where a cannot be 0, and the value of c is the y-intercept. So, quadratic form, got to know this. Okay. The other thing you have to know to be able to work with standard form is how to find the axis of symmetry. So you need this little mini equation, and this is probably new. X equals negative b over 2a. X equals negative b over divided by 2a. Once I find the axis of symmetry, that always gives me the x value of the vertex. So then to find y, I just plug it in. So some good things about this standard form, which I already stated, is that when looking at it, I can automatically tell what the y-intercept is. It just kind of jumps out at me. As opposed to with vertex form, the vertex jumps out at me. So different information, which is convenient for different types of problems. Example 1, find the y-intercept, the axis of symmetry, and the vertex of the graph of the function. I'm going to make a little answer key over here where I'm going to put all my answers. So the y-intercept, the axis of symmetry, and the vertex. So the problem I have is f of x equals 2x squared plus 4x plus 3. First thing I like to do is write down the formula. And I'm trying to write it so it's like in the same format and kind of lined up. The next thing I'm going to do is I'm going to make kind of a key over here of what is A, what is B, and what is C. So I'm going through and I'm comparing. So I've got my original problem on top and then the formula on the bottom. So what is A? A is the coefficient of x squared, right? So A is going to be this 2. And what is B? B is the coefficient of the linear term. So B is the number in front of x. And then C is the constant. So is the number without a variable. So we've got A is 2, B is 4, C is 3. Now, my problem over here automatically tells me the value of C is the y-intercept. So the y-intercept, okay, is always going to be this 0.0c. Now, if ever you forget that, we know that the y-intercept occurs when x is 0, so you can always just plug in 0 for x. This just kind of makes this pretty simple, though. So my y-intercept is when x is 0 and y is whatever c is. So y is 3. Done. It was the same thing up here. So I'm going to scroll up and look at these questions up here. So when I add or subtracted 0, right, I had a y-intercept of 0 for my red one. If I add 3, I had an intercept of 3 for my blue one. And if I subtract 3, I had an intercept of -3 for my green one. And that's always going to be the case. So the y-intercept is like the thing that pops out at us with this format. Okay, next thing, axis of symmetry. So for my axis of symmetry, I need a little mini equation, x equals negative b over 2a. Yes, you should know this by heart. And then I plug in. So x equals negative b, so negative b has the value of 4 over 2 times a has a value of 2. I'm left with negative 4 over 2 times 2 is 4. So I get x equals negative 1. Remember, my axis of symmetry is a line. It needs to be an equation. X equals some number. In this case, it's x equals negative 1. Okay, now to find my vertex, I'm going to take x equals negative 1, and I'm going to plug it in to my original equation. And this is where my order of operations is so important. I'm going to actually write down my acronym here so I can refer to it. So remember, the left-hand side says f of negative 1. That's the function evaluated at negative 1. The right-hand side, I need to simplify. Anytime I'm evaluating, simplifying, working with expressions, at all those times I have to use order of operations. So the first order of operation is P for parentheses. Look inside the parentheses. Is there any operation that I can do inside my parentheses? Negative 1 and negative 1. No, there's no operation in there. So I go to the next one, exponents. I have negative 1 squared. Negative 1 times negative 1 gives me a positive 1. Okay, I did my exponents. Now I go to multiplication or division, whatever I've got going on. Here I just have multiplication. So I've got 2 times 1, which is 2. 4 times negative 1 is minus 4, plus 3. And you should get 1. So f of negative 1 is equal to 1. That means my vertex, x is negative 1, y is 1. There we go. Okay. As for the y-intercept, got it. Axis of symmetry, yes. And the vertex, done. B is going to, the steps are all going to be the same. For problem B, I'm going to end up with some decimals. If you don't have a calculator handy, you might want to pause and go grab one. And I'll show you why the decimal pops up. All right, step 1, I'm going to write the equation. And then I'm going to identify my A and my B and my C. So what is A? What is the coefficient of x squared? All I have is a negative there, but I need a number, so I'm going to write down negative 1. Coefficient of B, I've got a negative 3. And then C, I've got a positive 10. Plus 10 or just 10 by itself is fine too. The C is where I get my y-intercept. So I have 0, 10. All right, step 2, axis of symmetry. X equals negative b over 2a. X equals negative of the negative 3 over 2 times a, which is negative 1. So negative 3 is going to give me a positive 3. And because the b is a odd number and the bottom is an even number, that's what gives me the decimal. So I get negative 1.5. I'm not going to leave it as a fraction. I'm going to put it as a decimal. That's what the online homework asks us to do. So the axis of symmetry is going to be the equation x equals negative 1.5. That decimal is not too bad. 3 divided by 2, 1.5. Next, I need to plug negative 1.5 into my equation so that I can find my axis of symmetry. Oh, this isn't called f of x, this is called g of x. There we go. So I'm going to go through, and everywhere that there's an x, I'm going to replace with a negative 1.5. So I have negative 1.5 minus 3 times negative 1.5 plus 10. Take it slow. Order of operations. Do what's inside your parentheses first. There's no operation inside my parentheses. It's just a negative 1.5. There's nothing to do to it, so I move on to exponents. Now, exponent says I have to do negative 1.5 squared. So you keep the negative in front here, because that's multiplication. Negative 1.5 times negative 1.5 is positive 2.25. I did exponents, now I'm going to multiply. Well, this is the same as having a negative 1 times 2.25. So I'm going to multiply negative times 2.25, and I get negative 2.25. Negative 3 times negative 1.5. 3 times 1.5 is 4.5, and a negative times a negative is a positive, and then plus a 10. This is where your calculator might come in handy. Negative 2.25 plus 4.5 plus 10 gives me a positive 12.25. All right. So my vertex is going to be the x value, which is my axis of symmetry, comma the y value, which is 12.25. Okay. Next, please pause the video and do problem C. Problem C isn't going to give you a decimal. It's going to be more similar to problem A, but I need you to practice it to see how it goes. Okay? Welcome back. Hopefully you had a good chance to try that out. I'm going to go ahead and write out the answer here. Hopefully you found that A is equal to 1, B is equal to 2, and C is 4. That allows me to find the y-intercept really easily. It's just 0, 4. When I plug in for my axis of symmetry, I get x is equal to negative 2 over 2, which gives me x equals negative 1. And then when I plug in negative 1 into my original function, negative 1 quantity squared is a 1. 2 times negative 1 is a minus 2. And then a plus 4. 1 minus 2 is negative 1, plus 4 gives me a 3. If you got 5, it's most likely because you were just a little, made mistakes with the positive and negatives. So the vertex should be negative 1, 3. All right, I'm going to go ahead and work through D also. You may notice as you write the formula here that not everything lines up. Because in problem D, I only have 2 terms, not 3. And this is possible, this happens. The key is which term is missing. It's okay to miss the linear term or the constant, but you have to have the x squared term in order for this to be a quadratic still. So it's okay to be missing the linear or the constant. I'm not sure if I said that right. It's not okay to miss the quadratic term. All right. So you'll notice I have x squared and x squared. So a is just going to be 1. And I don't have a b of x term. This one is a constant. So I'm going to write that in for a 0. I don't have it. It's missing. The minus 9 goes with a c. All right. Let me get that. Okay. Now when I plug in for my axis of symmetry, I get x equals negative b, which is 0, over 2 times a. Hopefully you remember this without having to use a calculator, but if necessary, plug in negative 0 divided by 2. Okay. Anytime I have a 0 in the numerator, I automatically have 0 for my answer. So 0 divided by anything is just 0. If I have 0 cookies and I divide that by 18 friends, well, I still just have 0 cookies. Okay. And then finally, for the axis of symmetry, I'm going to plug in 0. But when I plug in x equals 0, that's the same as the y-intercepts. This is 0 minus 9, which is minus 9. You'll notice that the y-intercept and the vertex are the exact same. That's because this graph, I'm just going to draw a little sketch for an explanation. This graph is centered on the x equals 0 axis, right? On the y-axis, which is x equals 0. All right, and it has a vertex at 0, negative 9. It's basically split evenly. It doesn't shift left or right. It's just x squared minus 9. So it's just shifted down 9. All right, great. In the next example, I am asked to compare g of x equals negative x squared plus 4x plus 4 to the graph of f of x below. Now, this graph down here is f of x, and they give me the equation for g of x. So what I'm going to do, I need to compare which one has the greater maximum value. To get an idea, the easiest way to do this is to take this g of x function and plug it in, graph it in Desmos, or in some other graphing app that you have. So I'm going to bring Desmos over, and I'm going to graph g of x equals negative x squared plus 4x plus 4. And then I'm going to compare the maximum values. Okay, well, looking at this problem right here, what is the maximum value? When I'm talking about minimum and maximum, this is always the y value. It's how tall or how far down I go, right? So when I'm talking about minimum, maximum, here's my maximum point. My maximum value is 5. Let's look at the graph of this other one. I think they called it g of x is equal to negative x squared plus 4x plus 4. Okay, so now I look at this graph. Okay, if I look at the maximum value here, here's my maximum. So there we go, is at 2.8. So my maximum value for this graph is at 8. Let's look at how that compares to my first one. This one, maximum is 8. I'm going to write that down as a note. Then it says which function has a greater maximum value. So we can determine that g of x has a greater maximum value at 8. And it doesn't ask me to write a reason, but I'm going to write a because here. And that's just so when you go back and look at your notes that you've got a reasoning. Okay. So g of x has a greater maximum value at 8 because the maximum at f of x is 5. This problem asks for maximum. Let's talk about looking at this and looking at the minimum. So just food for thought here. If I bring this graph back over and I scroll out and I scroll out some more and I scroll out some more and I start trying to look at like these minimum values, it doesn't matter how much I scroll out. Look at that. Like it's like 150 to 150, right? It still is going to go down forever and ever and ever and ever. This graph is never going to end in the negative y direction. So there actually is no minimum for that graph. It doesn't end at all. Okay, cool. Example 3. Write in standard form. Now, what I've got here is I've got equations in vertex form. Which is f of x equals a times quantity x minus h quantity squared plus k. And I want to rewrite those so that they're in standard form. In standard form, think of like the standard alphabet, right? ax squared plus bx plus c. So to do that, I basically need to multiply this all out and simplify it. So let's take a look at what's gonna happen here. When I start rewriting this, I have x minus 1 squared. X minus 1 squared means x minus 1 times x minus 1. Whew, I got some things to multiply out there. This right here, I'm going to pull that out and do that separately because it's kind of a lot going on. So I'm going to do this in two different ways to kind of give you a taste here. So I've got x minus 1 times x minus 1. One of the very popular ways we do this is distribution. So I just multiply through. X times x is x squared. X times 1 is, or x times minus 1 is minus x. Minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. When I combine like terms, I get x squared minus 2x plus 1. What I'm going to do back here is I'm going to plug in that new expression that I have. So x minus 1 times x minus 1, I know that that's x squared minus 2x plus 1. This multiplying of expressions here, we did this in 2.1, so you've seen it recently. Okay. If it's a little if you've forgotten it, you may want to go back and review. Here's another way that we went over how to multiply binomials. So we use this box for factoring. We can also use it for multiplying. So when I factor, I have everything on the inside filled out, and then I work my way outside. When I multiply, I have the outside filled out, and I work my way inside. So for here, I multiply whatever's to the left and above. So x times x gives me x squared. For the second box, minus 1 times x gives me minus 1x. For the box on the bottom left, x times negative 1 gives me minus x. Negative 1 times negative 1 gives me positive 1. You'll notice I have the same like terms, so minus x and minus x. Minus x and minus x is minus 2x, and then a plus 1. These are different methods to do the same thing. Just showing you both methods so that you can use what works well for you. All that did was do x minus 1 squared. Yes, you have to write it out twice. Yes, you have to multiply it all the way through. Let's go back to the problem on the left. I still have to multiply and simplify. So I have 2 times this whole parentheses and then plus 5. So my next step is going to be to multiply this through. So 2 times x squared, 2 times minus 2x, 2 times 1 gives me a 2, and then I have the plus 5 at the end. My last step is to combine like terms. And the only like terms I have is the plus 2 and plus 5, so that gives me a plus 7. So my answer is g of x equals 2x squared minus 4x plus 7. That is now in standard form. I'm going to go through and I'm going to write my steps. This is helpful for some people. So my first step was to write out the squared term. Okay, so this was step 1. Step 2 was to multiply out the binomials. And over here, this was step 2. Either way that you want to do it. Step 3 was to distribute the leading coefficient. Step 4 was to combine like terms. Which is just simplifying. Okay. So please pause this video and using these steps, go ahead and work out problem B. Pay special attention to the steps that I did in blue when you have to distribute all of those out. Please do on your own example 3, problem B. Okay, here's our solution. First step, rewrite out the squared term. So I have x plus 2 squared, which is the same as x plus 2 times x plus 2. Then I'm going to come on the side and I'm going to multiply x plus 2 times x plus 2. I'm going to choose to use the distribution method. You guys have multiplied this out over a couple of years, hoping we can get away from the box. But if you need the box, use the box. Whatever it takes to get it right. X times x is x squared. X times 2 is plus 2x. 2 times x is plus 2x. 2 times 2 is 4. So when I combine like terms, I get x squared plus 4x plus 4. So I'm replacing this with the new expression, the simplified, the multiplied out expression. Then I distribute whatever's in front. Negative 3x squared minus 12x minus 12. And then I have a minus 12 at the end. So I combine my like terms. And I get h of x is equal to negative 3x squared minus 12x minus 24 for my final answer. Thank you. Feel free to watch parts of this again should you need them. Bye-bye.